Alrighty. Hello, everyone. I have returned. I apologize for the long absence. However, I've returned bearing gifts. As you can see in the beginning video, I have created a aura effects HDA for you all. It does work on moving objects, as you can see. Alrighty, well, let's get into it and essentially show you how it works. So this button here, centralize, is for neutralizing the position of the actual character or object you have plugged in. You do not have to remove the shop material because it is automatically removing the shop material after it extracts the translation right here. I had a problem where the particles will spawn disk, and that was because of the shop material. So if your particles are spawning disk, that is why you need to remove the shop material, and it will work. Alrighty, you have that. Then you have this button that brings up the blast nodes interface, and you can select whatever parts you want to remove. Alrighty, that is that button. And when you select this, it doesn't matter what the viewer is on. I want to say I could put it on the particles, and you're still selecting the character piece that you want because that is where the blast node is located inside of the actual HDA. So it doesn't matter what part of the viewer you are on. If you want to remove it, you could just remove it by selecting the remove items and placing whatever you would like inside of here. Alrighty, now speaking of the viewer, I made this so that you could follow along because there are multiple states that this effects go through. And so I created a viewer for you to follow along in your process and easily jump back in between. Fun fact, I actually had an issue where when I added the animation back, because with the centralize, when it's not selected, the actual particle sim is actually still being centralized, but then it is being put back onto the character, so you can actually see the effects in context with your animation. Say you have a camera angle where you would like to see how the effects looks in context, then you can use that. So that is something to take note of, that the animation is actually still being, the particles are being ran still off of a character that is in the 0 position, the neutralized position. So there you go. And if you want to use an axis, you can easily just go into extract translation and change this value to 0. That is for the X, Y, and Z, and you will get the actual translation information back. Okay. I was thinking on, because that is something you may want, I was thinking on adding like a slot, adding extra around here to say if you would like to keep a translation. Maybe they'll be in version 2. I have to figure out how to make that look good, essentially, because I want to get this out to you guys. I've iterated on this, I want to say like 2 to 3, not 2 to 3, more like 3 to 4 times. Some of it was a interface overhaul that I had to do. I think that's where the actual viewer came from, and the remove items came from, was a interface overhaul, and along with the actual file caches that I've set up that came with it. So it's been iterated over many times, and it will still be updated. I'll push out updates because this is something that I use quite often. And when you see me create any type of effects that has like a aura type effect around it, I'm going to be using this. So I'm essentially giving you guys a tool that I'll be using as well. Alrighty. So now going along, again, the viewer, you want to change it as you go along and iterate on your simulation. So once you get done with this, this is the character setup. This is all you need for the actual geometry. Then you have the initial particle sim. And for this, I have the reset simulation button. Then you can change your substeps and your start frame to whatever you want. For the reference area, I like to use this expression because it generally gives me the right amount of particles, what I'm looking for visualizing what the simulation would look like without it actually being heavy. The one I actually like to use a lot is 1e minus 0.1. That usually gives me a good look, but not for this one. I need it a little bit more. And again, this expression I really like to use. I'm going to change this to manual so I can show you the expression that I use in the end is this 0.3 minus e, not minus e, 0.3 e minus 0.3. I put 0.5. This has been my bread and butter. This usually gives me around like, I want to say anywhere from 2 to 4 million. Really not 4 million, more like 3 million. So this is why I like using 0.3. I don't know why it is erasing things. 0.3 minus, 0.3e minus 0.3 is the expression that I use in the end to get what you guys seen. Alrighty, now going back. You have the reference area. That is what I just showed you guys. I'm talking in circles, so I apologize. So that is what that is about. Basically, density of the particles and how many particles you want to spawn. Life expectancy is how long the particles live. Variance, you have a variation within the particles. I like to have this be half. I mean, you can change it to a fourth if you like, but I like it at a half of the life expectancy. So I just had that set up. Alrighty. Then you have the big noise. Again, I am expecting you guys to go in and iterate on what I have set up, and that's why I have it set up in this way that you can read it easily and see what each part is doing. Is because I want you guys to go in and add your own variables. But this essentially was to give you a strong base, and then you take this and go forth and do crazier things with it. but this is to give you a strong base. So going in, you can see the two noise giving you two curl noises. I have it on Perlin, but you can do the analytics fast, simplex, but for this I like the Perlin noise, so I kept it on the Perlin noise. Alrighty, so you have that. The big noise and the small noise, those are the two noises. Now, when you look at the initial particle simulation, you are looking at the density, and this is what the density will look like for you if you were to pump it into the pyrosim, which is already set up. So when you see it, if I revert to defaults, it will look like this. What I do is just have it go to 1 around the middle of the lifespan and then back to 0 towards the end. And it gives me this type of look. I found this to actually give me good results when I plug it into the pyro simulation. And then if you like how it initially looks coming out of the initial simulation, that's what I have this for. Or maybe you would like to not have two simulations being ran at the same time with the pyro simulation and this, so you would like to cache it out. I have this set up for you to cache it out. When you retarget the simulation, it will take the actual animation information. It will not into the actual simulation, the initial particle simulation, but it will retarget the simulation back to the animation. So just to clear it up, the animation is still being ran. The simulation is still being ran off of the neutralized animation. The neutralized translation. Well, that's that's a mouthful. The neutralized translation. It is still being ran off of that. However, when you press retarget, it will send that simulation back to the original animation in the original position. I have this, so say you like what you have from the initial particles and you don't want to go on from here to the actual pyro simulation or the final particles, you can just place it back on the animation and then save it to disk and then load from disk. Or you could just save it and not run two simulations at one time. My computer really didn't have an issue with that, and as long as I keep the particle numbers low, I really don't run into any issues running the initial particle simulation with the pyro simulation. Again, you want this number low because you want to just get the look of the aura effect, not really have the final particle number being pumped into the pyro simulation, because that will give you a lot of volume. So once you have this set up and you like how it looks, you would then go over to the pyro simulation. I'm going to have that set to 1, and then we're going to swap over to the pyro simulation. And I think I have this. This is acting up because I have it file cached and it's loading from disk. I think, yeah. So if you swap over to the pyro simulation, for some reason this is automatically set up to load from disk. I've tried to fix it. Be on the lookout, because this may be still selected as load from disk. I will try to have that fixed. However, still be on the lookout for it because that may be the reason why you don't see the pyro simulation initially. But let's go over this. So you have the same setup where you can select the simulation type. I thought it was cool. You can select in between sparse and dense and even OpenCL if you would like. For me, I rarely change this. I really don't change this a lot. I just thought it would be cool if you guys seen it as an option, essentially. So you have that. You have the start frame, the minimum subnet, uh, the minimum substep, and the maximum substeps. The voxel size, the density scale. This is a parameter that I have added. If I go into the actual Pyro solver, you can see I have a expression right here that is creating that parameter, multiplying the density that's coming in by this density scale. And so that is what you're seeing up here, the density scale. Then you have the time scale that is connected to the time scale of the Pyro solver. And then from here you have the velocity. And here I took the shape tab and brought it up one level so you can actually shape your pyro simulation. Okay. Then you can see the values. I think I used the default values and really drove the look of the pyro simulation by the initial particles. I don't know why I have it on blend, but just change it to a pull operation. Fun fact, the reason why you see these separate and how this one looks different from this one is because I had to reconstruct it. I I had to reconstruct the layout. This is before I knew how to bring up different pieces from different nodes. So it was a fun little, I'm gonna say, a side project, just recreating the nodes and seeing how the nodes are being built up. Also, seeing how I could use some of these aspects inside of any Python script that I write. Because as you can see, when you hover over it, you can see the parameters, and you need those. Like the parameter names, you need those for writing scripts inside of Python. As you can see, and I use those to manually link for the file cache. I had to manually link the save to disk button to the file cache. I think the name is input, if I'm correct. No, execute. So the parameter name is execute. So I had to link that up. Okay, I'm getting sidetracked. Let me get back to the actual simulation. Okay, so that was cool. I had to set that up manually. A lot of this interface is manually set up. However, that is not the reason why I have the video made. Let me let me get back to the actual simulation. So I really use the default value and carry the look of the pyro simulation by the initial particle simulation. And then you take that information. Now, this is something you want to save out. Like, I want to say this step is necessary. You want to save this out as a VDB, and the values you would get from it. As it, you're getting only the density and the volume, so it should be a light file. This you want to save out because you're going to be spawning a lot of particles on top of that simulation. You do not want to run both of these simulations at the same time. So save that out and then have the pyro simulation, have the final particle simulation run off the pyro simulation. So I'll have that set up and then we will get back. And we are back. So I have saved out the file, as you can see. Now with this, I have retargeted it back to the animation, so that's why you see it going up and down. But you can see it is running off of the pyro simulation that we have just saved out. And now let's go over the final particles section. This part is essentially the density from the beginning. So you're setting the same density, but if you want to add any type of offset, you can do that. I didn't. Then again, with this expression, I got 2 million, well, almost 2 million particles. And that gave me a decent result. If you want more, you can always up either side of this. I will say this side is more exponential. You could jump, I want to say, like 2 million particles just by going from 3 to 4, 0.3 to 0.4. But if you want a value in between that, then I would say change this over here to like 0.2 or maybe even 0.1. But then again, if you want a lot more, then change this side of the equation. Okay, so this value here, the p-scale, this is the information that tells Solaris the USD level. And I said that in a funny way, but we will move. So this is the value, as you can see, p-scale, that this will be taken into Solaris, and we will use that and multiply this value by the width value in the Solaris section, and that will give you a decent scale on the particles. So that we will get to, but for now, you will have this button right here. If you don't have it selected, then you will just see the particles color and you will set this up to however you like. Now, if you didn't notice, this can be changed based off of not based off of, but after you've cached it. So the color is independent and the P scale is not, these two are not being cached out. So you can change this even after you have saved the simulation. So you do not have to keep resimulating to change values. It is just set up so that you get the look that you want and then save it. But you can operate on it after you save it with the P scale and the particles. So the particles color. And as you can see, again, the setup is the same, a little bit less that you can do because it's just taking what you've already done and iterating over that. But again, you can just go into the file and then go over here, and you can see where the actual color and P scale is after the file cache. So you do not have to worry about recaching it every time you want to change the value. So the popnet is right here, and you can see your character is being taken into the equation, or your object is being taken into the simulation, taken into consideration for the simulation. I did not leave that out. Where is it? You can see it. Bringing in the sources, and that is all that is happening in this popnet. So you have that. Let's go all the way back down here. And you get that final result. So if you want one color, then you can just work on one color. But if you want multiple, you can have multiple. And as you can see, it even has its own color along the lifespan. So you can set it up how you want based off of the bias noise. You can change the bias to whatever you want. It should change. Don't know why that's not, but it should. And it will be linked when you guys have it. But based off of that noise, you will have your bias set up. You can have it as sharp as you like. Again, these will be set up. I do not know why they are not connected now. But they will be connected when you have it. And so you will change your bias, and this will change how sharp it is. The transition between your first color and your second color, if I go back into the actual file, you can see that, not down here, but right here, you can see that the colors are being blended together by that bias value. So that is why the bias is being cached out. That is the issue on why you are not having it updated. So we will fix that in real time. Just place it afterwards. So there you go. You can see the bias change and update real time. And based off of the value, you can change how much of it you like. And the noise, that kind of looks cool. There you go. I did use this in the end, however, I changed it in post because I did not like how it looked. I liked how it looked inside of Solaris. Outside of it, I did not like how it looked, so I changed it. But yeah, there you go. Okay, so that is the Aura Effects HDA. Again, you plug in your character, you go along with the viewer, you can remove anything you want. Keep this selected if you want to keep the thing removed. Keep this enabled, because if not, it will toggle back to keeping everything. So keep that on. Have whatever you don't want a part of the simulation in this box. Then change your noise. Change the initial velocity again. Have that on so you can see it, and it's kind of cool. You can see how your particles are going to move. The velocity direction, as you can see, changes its strength. I mean, if you want to go left or right, either way you want to go, you can have that set up however you like. Again, I try to keep it very flexible, but and give you a lot of options so that you do not have to frequently go into here, but you may. Especially with this, if you don't like the noise, then probably have to go in and change it. Maybe you don't want a curl noise. Maybe you want a anti-alias flow noise. Then you can go in and change it. But as of right now, you have the big noise, the small noise. You have the density. Again, have this off before you go into the PopNet. But when you're working on the initial velocity, have that on to give you a good visualization. When you go back to default, these values are set as the default, so you do not have to worry about it being set back to 0. Just go revert to defaults and you should be good. Then you have the small noise set up. Again, the density. If you like what you see and you want to keep that, or you don't want to have two simulations running at the same time, save it out and keep load from disk. Now, if you would like to have the centralized animation moved and then use that going into the pyrosim, you can. I have no drawbacks with that. I just didn't do that. And there you go. Yeah, these are all set up. Okay. And these are the default values that you will get. I do revert to default, so you see it's grayed out, but if I change this to like 11, I did revert to defaults. It goes back to 10. So is the density scale. Again, this is the default value. If I go to 0.1, revert to defaults, it goes back to 0.9. 0.9 is almost the full pyro, 10% less. So The lower you go, the less volume you keep. So you have that set up. Save the file. This will be defaulted to BGL. You want to save this out as a VGB. Nothing will change if you have it as a BGO, like the final particles will still go off of that information. However, you will not be able to use that volume inside of Solaris. So if you want to use that volume, save it out as a VDB. I almost said DBZ, which you can use this HDA for. Okay, now going into Solaris, I'm going to have this on manual. I do not know where I have it set up. So heading into Solaris, see I have it set up kind of funny, but it will all make sense. So we're going, I want to say, we're going to go to here. This is what I wanted to show you. So here, I had an issue where I was saving out 2 volumes, one to actually render out and the other one to run the file cache on, the final particles on. So I was going to find a way to have it inside of the HDA so that it ran and used one file cache for both the repositioning and having it saved out the reposition and have the final particles have a station pyro simulation to work on. However, as of right now, I couldn't find a way to have it be one file cache that does that. So this is the workaround, or maybe just the way to do it. You want to save it out stationary as it is, locked to the neutralize position right here. And then in here, the instancer, you can bring in that target point. That's why I have it saved out as a target point. You will see the null is called the retarget point null. Take this null node right here because it has the retarget point that everything is being retargeted to. Have that be brought into the instancer. And there, it will place the volume back onto the animation. And it will go up and down as it would if you actually saved it with the retargeted simulation. Essentially, it's doing the same thing that it does inside of the HDA. It's just doing it on the stage level. So, going here, it's kind of messy, but it works. Again, you're taking the width attribute and multiplying it by this. I just needed P scale to remind myself that you are working on the P scale. And that is what this attribute is taking in. So you're taking the value that you set on the object level, the P scale, you're taking that value and then multiplying it by this new parameter, which is named P scale, to remind myself that you are working on the P scale. And then you can take that in. Ooh. And use the color that you set inside of the object level as the color, any emission color. And then there you go. You will have your simulation set up. Your aura particle simulation. And let's go down to the object level. Have this on the final particles. The final particles, and then go over to the tab. And let's just get a look on what I saw. Okay. Particles are being brought in. Then they are being rescaled. As you can see, when they first come in, they're being rescaled by this expression. Have the run on elements of array attributes on, and then have it point all the way down to the actual points underscore 0. Whatever naming convention you have the pathing go all the way down to let's see, particles. Have it go all the way down to the points underscore 0 for this. And then that should work. And then after setting it up, you have this. Your aura particles. Doesn't that look cool? And then for the pyro, if I click right here, I had it saved out in a different fashion. I didn't use the same lighting setup. I found a little hack is having the volume rendered out in a neutral lighting gives you a little bit of flexibility when it comes to compositing, because I was able to change this into a purple pyro simulation or pyro smoke simulation in post. And in a previous video that I posted in the shorts, I used that method. I saved out a pyro simulation in neutral lighting and then subtracted that simulation from the actual composition to get the black smokes effect. The black smoke effect that happens around the guy. Okay, so you have that set up. And again, I will have this set up similarly. Like you will have the actual file in the stage composition, so you can look at how it was set up in the stage level. Along with the HDA itself, with everything hooked up. And again, everything is hooked up now. I think what was happening beforehand is that the bias was being cached out, so you couldn't change it. Again, you can see that's kind of weird, kind of cool looking. And you can have your fun with this. maybe if you wanted some different variation, you can add that in. But again, if you don't want it, just turn this off. And you will have one color. Alrighty. Alright guys. Hope you enjoyed. I know this is long, but again, there is a lot going on. A lot of moving pieces. I want to see if I didn't cover anything about this. I feel like I have. Again, when you use this, it will be taken into consideration. When you have this enabled, it will be taken into consideration when operating the next simulation. But when you have centralized, disabled, you will have the animation moving, but it will not be cached out that way. So the simulation will be moving, but it will not be cached out. If you want the simulation moving with the animation, it will be moving, but it will be stationary. If you want it to move with the animation, you will have to have the retarget simulation enabled. And then for this one, you want it enabled and just save it out. And then you have your final particle simulation. Thank you guys for watching the video. I hope you guys enjoyed. Drop in the comment section below your experience with the HDA. I will be reading the comments and making changes and adjustments based off of that. So I would love to see you guys' feedback inside of the comments. I will try to have a community set up that you guys can show your results using the HDAs that I put out. But until then, again, leave your reviews in the comment section below. I will be reading and will be trying to update the HDA based off of your feedback. All right, thank you guys, and I'll see you guys in a later video.